All right, folks, let's tackle another differential equation. This time we have the equation y prime minus 2y is equal to e to the 2x. We are also given the initial value y of 0 is equal to 2. This comes into play later on. It can help us determine the constant. So we can go ahead and just tackle this the way we would do with using the method of integrating factor, because we notice this is not a separable differential equation, but it is a pretty simple one to solve. We just need to find the integrating factor. Remember that we can find the integrating factor if we have an equation of the form y prime plus p of x y is equal to q of x. And if you recall, we can find the integrating factor by doing mu of x is equal to e to the integral of p of x dx. That will help us find the integrating factor, and from there we can multiply this whole equation by the integrating factor. So what is p of x in this situation? She's going to be equal to -2. So it's a pretty simple one to solve. We have e to the integral of -2 dx. So we're going to get mu of x is equal to e to the -2x. So now that we have our integrating factor, our mu, we can go ahead and multiply everything through by this e to the -2x. So what are we going to get? We're going to get e to the -2x, y prime, minus 2 e to the -2x times y is equal to 1, right? E to the -2x times e to the negative. Yep, it's going to be equal to 1. So now, as before, the whole point of the integrating factor, we can recognize this as d. On the left side, we're going to have d dx, the derivative with respect to x of y times the integrating factor. And what's the integrating factor in this case? It's e to the -2x. Is going to be equal to 1. So from here, we can just use some good old integration. We're going to integrate with respect to x. And on the left side, the d dx is going to cancel out. So we're going to get y e to the 2x is equal to integral of 1 dx. So what does that leave us with? Well, it's some simple integration. We're going to get y e to the -2x is equal to x plus some constant c. So almost done here. We can get y of x is equal to, we can multiply each side by e to the 2x. We're going to get e to the 2x times x plus c. So here we found an equation of y in terms of x. We're almost done, but we also are given this initial value. We're given y of 0 is equal to 2. So if we go ahead and plug in 0 for x, we can get y of 0 is equal to e to the 2 times 0 over time, not over. So x is going to be 0, so 0 plus c. E to the 2 times 0 is just going to be e to the 0, and e to the 0 is just going to equal 1. So this is all going to end up just being c. And we know that this is all, and given our initial value, y of 0 is 2, so we're going to get this is equal to 2. So from this, we're going to get c is equal to 2. So all in all, we solve for our constant now. Now our final solution is y of x is equal to e to the 2x times x plus 2. And again, like always, if we plug this in up here into our original equation for y, if we differentiate it and get y prime, we will get that it solves this initial differential equation with its respective boundary condition.